Hi, I'm Herb Gross, and welcome once again to our Math as a Second Language lecture series, where today we're going to be discussing the multiplication and division of signed numbers. And it'll be mostly multiplication because division is just unmultiplying, and it only takes a few seconds to give the rules for division once we have established the rules for multiplication. And again, as I mentioned earlier in one of the lectures, my first exposure to working with signed numbers was in terms of profit and loss. And profit and loss is a very nice model for multiplication up to a certain point. And let me show you what I mean by that. See, remember, we said that in terms of the profit and loss model, a $3, positive 3 times positive 2 means a $3 profit twice, or a $2 profit 3 times, okay? Now, if you make a $3 profit twice, that's a $6 profit, so that would be positive 6, and so we've established that positive 3 times positive 2 is positive 6. Now, what about positive 3 times negative 2? Well, you can't have something happen a negative number of times, so this must mean you've lost $2 3 times, and a $2 loss 3 times results in a $6 loss, which is negative 6. So positive 3 times negative 2 is negative 6. That sounds okay. And how about negative 3 times positive 2? Well, again, you can't have an event happening a negative number of times. So negative 3 times positive 2 must mean a $3 loss twice, and a $3 loss twice is a $6 loss. That would be called negative 6. And so now finally we come to negative 3 times negative 2. And we're in trouble because we can't have an event happen a negative number of times, and yet both of these nouns here are negative. And this is an important point for us to pause, because what happens is a model is okay up until a certain point. One of the reasons that you need generalized rules is to take care of the situation where a model doesn't apply. This came up in division. If you're dealing with whole numbers, 7 divided by 2 doesn't make much sense, either mathematically or physically, if all you're dealing with is whole numbers. For example, 2 times 3 is 6. That's too small. Basically, the idea is you can't have 7 divided by 2 is 3.5. You can't have 3.5 people. But you can have a piece of string that's 7 inches long and you divide it into 2 equal parts. So somehow or other, there must be another way of getting at what does negative times negative mean. We just can't use this particular model for it. Well, there are a lot of different ways you can do this. This is one case where I'm going to save the adjective noun theme for last, just to show you what a profound difference it makes in terms of being able to get to the result very quickly. And the ways I'm going to show you now could be done either before or after you've introduced the adjective noun theme. I feel that they make much more sense. Either way, the adjective noun theme, whether it's coming first, it's a personal preference type of thing. But let me show you how certain things are done without the adjective noun theme. Negative 3 times positive 3. We already know that 3 times 3 is 9. Negative times positive is negative, so that would be negative 9. Negative 3 times positive 2, in a similar way, would be negative 6. Negative 3 times positive 1 would be negative 3. Negative 3 times 0, whether it's plus or minus 0 doesn't matter. I should say positive or negative 0 doesn't matter. That would be 0. But now we come, see, look what's happening on this chart. If you look down the first column, every entry is negative 3. It's all a multiplication sign. And do you notice that the numbers are decreasing sequentially? And what's happening over here? This may look strange to you at first glance, but what's happening over here is as you read down, the numbers are increasing as we go along. See, the adjective 9 is greater than the adjective 6, but a $9 loss is a worse loss than a $6 loss. In other words, you have to make $3 to convert a $9 loss into a $6 loss. So as you go down here, each row is 3 more than it was in the previous row. So if we want that to continue, reading down here, this is increasing by 3 each time. So 0 plus positive 3 is positive 3. Positive 3 plus positive 3 is positive 6. And so this method here would say, if you want this to be true, negative 3 times negative 2 has to equal positive 6. Again, a very, very important thing to notice in math. Every time you say something, there's going to be an if involved. In other words, without assumptions, there can't be any proof. So in other words, what we've done over here doesn't prove that negative times negative is positive. What it does say is, if you want this array to continue the way it is, negative 3 times negative 2 is going to have to equal positive 6. Now, another method is to notice that if you're assuming that the cancellation rule holds, again, see that if? See, if positive 3 times positive 1 was equal to positive 3 times negative 1, you could just cancel out the positive 3's, and you'd have the impossible result that a $1 profit is the same as a $1 loss. That would mean sort of saying the same thing as multiplying by positive 1 is the same as multiplying by negative 1, which we know isn't true. So we know that negative 1 times positive 3 can't equal positive 1 times positive 3, but we also know that positive 1 times positive 3 is 3, positive 3. So negative 1 times positive 3 can't equal positive 3. There's only two nouns. If it can't equal positive 3, it has to equal negative 3. And what we notice is that multiplying positive 3 by negative 1 kept the adjective the same, but it changed the noun from positive to negative. And the same thing happens if we start with negative 3. Negative 1 times negative 3 can't be the same as positive 1 times negative 3, because otherwise you could cancel the negative 3's and get that negative 1 equals positive 1. But positive 1 times negative 3 is negative 3, and since negative 1 times negative 3 can't equal negative 3, it has to equal positive 3, because the magnitude is still going to be 3, so the only way they could be different is in sign. And that says that multiplying a number by negative 1 just changes the sign of the number. In other words, in the same way that multiplying a number by 1 doesn't change it, multiplying the number by negative 1, okay, is going to just change the sign of the number. And that gives us, knowing that, and knowing the associative and commutative properties, we can now show that negative times negative always has to be positive. And let's just demonstrate that with negative 3 times negative 2. To change the sign of negative 3, we just multiply it by negative 1. Okay? In other words, positive 3 times negative 1 is negative 3, and positive 2 times negative 1 is negative 2. Now, by the associative property and the commutative property, we can rearrange these numbers here, these factors, so that the positive 3 times the positive 2 is done one way, and then negative 1 times negative 1 is grouped over here. Now, multiplying by negative 1 changes the sign of a number. So if that's the case, multiplying negative 1 by negative 1, we already said that comes out to be positive 1. Positive 3 times positive 2 is positive 6. Positive 6 times positive 1 is positive 6. And that's basically all we need to know here, because the 3 and the 2 could be replaced by any numbers. The same construction here would work, only the other numbers replacing the 3 and the 2. Another thing that we might want to preserve is what we call the area model. In other words, let's suppose you were asked to compute the problem, positive 7 plus negative 3 times positive 5 plus negative 2. Now, in a case like this, I don't think you would use the distributive property, the area model. More likely you would say, hey, I know that positive 7 plus negative 3 is equal to positive 4. I know that positive 5 plus negative 2 is equal to positive 3. So this is the same problem as positive 4 times positive 3, which I know is positive 12, okay? On the other hand, if I did want to use the area model, the positive 7 would multiply the positive 5. The positive 7 would also multiply the negative 2. The negative 3 would multiply the positive 5, and the negative 3 would multiply the negative 2. Okay? Now, positive 7 times positive 5 is positive 35. Positive 7 times negative 2 is negative 14. Negative 3 times positive 5 is negative 15. Negative 3 times negative 2 is the one we don't know, but we do know that when we're all done, the answer has to be positive 12. Well, a positive 35 and a negative 14 adds up to positive 21. Positive 21 and negative 15 adds up to positive 6. So what this tells us is that whatever negative 3 times negative 2 is, when you add it to positive 6, you have to get 12. What number added to positive 6 gives you positive 12? The answer is positive 6. And that shows why negative times negative has to be positive. And at this point you might say, why in the world would anybody do the problem this way when it's so much easier to do it this way? And this is why I said when we first started talking about sign numbers that they really become important when you're doing algebra. You see, in algebra you don't have specific numbers. You might have A plus the opposite of B multiplying C by the opposite of D. And now when you use the area model, everything goes fine. The A times the C is okay. The A times the negative D is okay. The negative B times the C is okay. But what happens over here? It's the opposite. I said negative over here. Maybe I should have said opposite. The opposite of B times the opposite of C. Somehow or other, I can't put numbers in here. I have to just work with the nouns themselves, and that's why this rule is so important, okay? Not so much for arithmetic, but more for algebra. Now, let me show you the power of the adjective noun theme. If some of these methods seemed a little bit cumbersome to you and things that it made it seem like you'd want to memorize these things, that's exactly what I wanted to happen. Because I want to show you how simple it is, even though it may not be intuitive. That's why these other methods would be nice to check that you actually do get the same result. But here's the thing. In other words, 3 times 2 as adjectives is always 6, never changes. However, what the 6 modifies depends on what the 3 and the 2 modify. So now let's look at positive 3 times positive 2. And I'm going to write this out in this rather strange form to emphasize that the 3 and the 2 are the adjectives and the sign is the noun. I'm going to use pos to abbreviate positive and neg to abbreviate negative. So this is 3 pos times 2 pos. By the adjective noun theme, we know that we multiply the 2 adjectives, that gives us 6. We multiply the 2 nouns, which means we write them side by side. So the answer would be 6 pos pos, whatever that means. Well, there's only 2 possibilities. Pos pos has to either be positive or negative. Let's see what happens. On the other hand, we know that positive 3 times positive 2 is the same as 3 times 2, which is 6. 6 is the same as positive 6. And positive 6 can be written as 6 pos. So in other words, we have 2 different ways of representing positive 3 times positive 2. One is 6 pos pos. The other is 6 pos. There's only two signs, positive and negative, so it shows that positive times positive equals positive. You say, well, that's easy enough. I don't understand what's the big deal about that. Well, now let's see how we can do why positive times negative must be negative. Let's go back to our basic definition. Positive 3 is 3 pos, negative 2 is 2 neg. How do we multiply? Again, we multiply the 2 adjectives. The 3 times 2 is still going to give us 6, but now the unit is pos neg. Now what does pos neg mean? There's only 2 nouns. It either has to be positive or negative. In other words, no matter what else might happen, positive 3 times negative 2 has to equal either positive 6 or negative 6. Let's assume now, see what we're going to do is there's only 2 nouns. If I can show you it can't be one, then it has to be the other. That's the beauty of having only 2 nouns. So let's look at positive 3 times negative 2. Suppose it was positive 6. Well, we already know that positive 3 times positive 2 is positive 6. If positive 3 times negative 2 was equal to positive 3 times positive 2, you see, what would happen is by the cancellation rule, we could cancel out the positive 3's and conclude that negative 2 equals positive 2. Since we know that negative 2 can't equal positive 2, and since we knew that that came from the assumption that positive 3 times negative 2 was positive 6, it means that positive 3 times negative 2 must be negative 6, so positive times negative must equal negative. And by the commutative property, if positive times negative is negative, just switching the order, negative times positive must also be negative. And that brings us to the one that we couldn't do using the profit-loss model. Namely, -3 times -2 means what? 3 neg times 2 neg, that's 6 neg neg. Now remember, neg neg has to either be positive or negative because there's only two nouns. So either -3 times -2 is positive 6, or else it has to be -6. Well, let's suppose that it was -6, and we'll show that that leads to a contradiction. If -3 times -2 equals -6, okay, we also know that -3 times +2 equals -6. That being the case, using the cancellation law again, we could cancel the -3's and conclude that 2 equals -2. Since that can't happen, it must be that -3 times -2 can't equal -6, therefore it has to equal +6, so the product of two negative numbers is positive. And again, people sometimes make light of this, I may have mentioned this before, by saying, well, what did you expect? It's double negation. Yeah, it is double negation, but so is it's double negation when you add -3 and -2. The answer isn't +5, it's -5. A $3 loss followed by a $2 loss is a $5 loss. At any rate, to summarize, here's the four sign combinations for 3 and 2 multiplying either positive or negative. And if you look at our chart, +3 times +2 is +6, +3 times -2 is -6, -3 times +2 is -6, -3 times -2 is, again, +6. And what do we notice? No matter what the signs are, the adjective part of the answer is always 6. And when is it positive? Whenever both factors have the same sign. When is it negative? When they have different signs. Now, after we've done all of this, notice what a short summary we can give if all we want is for the student to commit this to memory, okay? The magnitude of the product of two sign numbers is always the product of the magnitudes of the two sign numbers. The sign of the product is positive if the sign numbers have the same sign, but it is negative if the sign numbers have opposite signs, different signs, okay? Now, you can memorize that. How long are you going to retain it? How long are you going to be able to work with that and not confuse it with what happens when you add two negatives and the like? And I said that we can give short shrift to division once we know multiplication. Let me show you that's the case. Let's work with 12 divided by 4 with the 4 possible signs. We know no matter what the signs are, the 12 divided by 4, okay, is always going to give me 3. Now I got to figure out what the sign is. What do I multiply a positive number by to get a positive number? The answer is positive. What do I multiply a negative number by to get a positive? Well, negative times positive is still negative, so I have to multiply that by what? A negative number. Okay? What do I have to multiply positive 4 by to get -12? 4 times the 3 gives me the 12. This should be negative, because positive times negative is negative. And finally down here, what do I multiply -4 by to get -12? The answer is +3, because -4 times -3 would be +12. And what do we see? Exactly the same rule mechanically as we had for multiplication. Namely, to divide two sign numbers, we divide their magnitudes and call the quotient positive if the two numbers have the same sign, but negative if they have different signs. And this has been a very lengthy, in terms of the amount of computation, this has been a fairly lengthy lecture. Again, you can watch the tape, the video as often as you wish. You can pause it, etc. But let's summarize now by our usual practice problem, that you will pause the video, work the problem, and then come back and hear my solution. And the practice problem is, what is the flaw in the following argument? The product of two sign numbers is always positive if the two numbers have the same sign. Well, here's a negative sign, here's a negative sign. Therefore, -3 times -2 squared is a positive number. what is the flaw in this argument, okay? Pause the video, and when you're ready, come back and watch my solution. The thing to notice is that when you write -2 squared, the whole number, -2, is being squared. In other words, the number that's being squared is what's inside the parentheses. Negative times negative is positive. So when you have -3 times -2 squared, you don't have the product of two negative numbers, you have the product of three negative numbers, because -2 squared is -2 times -2. So in other words, the problem becomes -3 times -2, which is +6. +6 times -2 is -12. Okay? And so there is the contradiction. We're not multiplying two sign numbers here, we're multiplying three sign numbers. And that makes it important because of reading comprehension. In other words, when you're looking at this problem, it's easy to overlook the exponent. Don't overlook it. Okay? And also notice that it makes a difference whether you're squaring the -2 or whether you're squaring the 2 and then taking the opposite of it. See, in other words, -2 squared is +4. The opposite of 2 squared, see, 2 squared is 4, that would be -4. So this is -3 times 4. This is -3 times -4. And to generalize this, every time you multiply -1 by itself, you get +1. So every time you raise -1 to an even power, you'll get +1. Every time you raise -1 to an odd power, you get -1. And see how that follows here? See, we can think of this as -1 times 3 times -1 times 2 times -1 times 2 again, and we're multiplying -1 by -1 by -1. That's the third power, and that's always equal to -1. Well, anyway, this brings us to the end of today's presentation. Next time we'll pick another topic. I shouldn't say we'll pick. We will work on another topic called exponential notation. We will be working with exponents. Again, I don't know how much of this you need in arithmetic, but it becomes very, very important in algebra. And I'll try to give 2 lessons on this, one of which emphasizes it from the arithmetic point of view, the other from the algebra point of view. But until next time, study hard, have fun. I'm looking forward to seeing you again soon.